Thank you. Good morning. It's truly an honor to be here. This is a technology platform that I feel very passionate about. You can ask half the people at Goldman and even my wife how passionately I feel about what Spark brings to the table. I do think it's also a pretty unique time in what's coming together with technology platforms like Spark and the cloud, and I'll get to that in a second. So let me talk about a little bit how I got, what's my Spark timeline look like. Just to make this a little bit of an interactive keynote. Can I just get I can see that, can I see just a show of hands? How many people were at Hadoop World back in October? And basically saw how Spark came on to the, right, so a good percentage. I feel for anyone who came to Hadoop World with a product that didn't either use Spark or was somehow embracing Spark for it to deliver the product. And it really took over that conference, and it was at that point that Spark came onto my radar, and it became clear to me that this was something that we had to embrace as quickly as possible. And where it was starting to spread, that Spark was coming onto the scene, with some hints from people at the conference. I stumbled into Michael's Spark SQL talk, and realized how transformative it was and how it was becoming the missing piece that everyone was missing. I then saw the replay of Ollie's rockstar demo of how it made things, hard things possible and simple things simple. And then I wrote it up when we got back to Goldman, and it spread as my first big viral hit. So what I'd seen and what I posted on our social media was I'd seen the future, and it was Apache Spark. What did I see in Apache Spark that made it so game-changing was sort of what you see when you first, to the same extent that when you first held an iPhone, or when you first see a Tesla, right? There was something completely game-changing that really blew me away to so much of an extent that I was, for a second, when I sat down in Michael's talk, I thought maybe I was being put on, and it was so much exactly what we were looking for that maybe these 200 people in the audience with me were all extras, and this was all set up just to get me, it was eerie. What about it made it so game-changing was, it basically had, cross-platform capability. It combined, relational, functional, iterative language constructs to express what you were trying to do without going through all the boilerplate or all the, conversions back and forth to SQL or not. You could express your algorithm in the way that made it most obvious and most down to the point of what you were trying to do. It was storage agnostic, which I think was the key insight that what Hadoop had been missing was that people were thinking about how to put compute on HDFS, not that you want to do compute that can pull from HDFS or other places. Lambda closures, I think they would have had me at Lambda closures. And and what was also eerie was that we had seen, not to the same distributed extent, but we had seen a lot of success in a very eerily similar abstraction in our own internal Goldman platform on how we express data sets that was independent from where the data came from. So it instantly resonated with me that this was exactly where we wanted to go, but just had the beautiful abstraction on letting you leverage the power of distributed computing. And the fact that it was embracing Scala as the way to enable this was, again, eerily timeline lined up for what we were already starting to do with Scala. So how does this fit into the picture? Like, where does Spark fit in, particularly in the enterprise context? And I'm going to try to share with you today some insights we've had and how Spark fits into the enterprise now, and how you can embrace it now. And I wanted to share some of those insights just to sort of press that along. So there's really three elements, three dimensions of elasticity. in the big data space is data storage, compute, and user scale out. Right, clearly, Spark fits into the space of compute elasticity, right? And that was a key gap that got filled instantaneously, and it's no surprise why this is why this is caught on, and it had been missed up until that point. But first, again, another show of hands, just so I can calibrate in real time, for the rest of the talk. How many people, and keep your hands up for each of these three questions. How many people have used a proprietary data, proprietary in-house built data analytics framework? Everyone at Goldman should raise their hands, obviously. Great, keep your hands up. How many people have written their own? I've actually written the data analytics framework that for some proprietary purposes. And lastly, how many people have more recently wrapped a framework around Spark itself? Okay, so we have a good sizable piece of the audience. Don't do that. Right? A lot of really creative thought has gone into these APIs that are very important at this stage in time to embrace. And I'll explain as we go. But the abstractions are good. And even more importantly, they're getting better in a very, very quick amount of time. Data frames, which everyone thought clearly we had to start wrapping our own data frame-like API around Spark, clearly are now part of the platform. Right? And it's happening very fast and at an accelerating rate. Secondly, Spark is becoming, which is a great thing, the lingua franca of big data analytics. We should all embrace this. Right? This has a compounding effect that we can all contribute to. And then in that light, and given how this has been set up, we should all be thinking about building the muscle memory involved to become active contributors in this space. For everyone who raised their hand, on either, particularly the ones who are building analytics frameworks or wrapping or using, you all have core competency in this space to contribute back and engage. Right? This is, unfortunately, a lot of enterprises, we just don't have the muscle memory. We've got to get through this. We can all help shape the platform, which has already started happening clearly since we're all here. But there's even more opportunity in the enterprise space, which I feel has locked up a lot of capacity here that we can all be engaging. If you have a creative idea on how to improve the platform, contribute it back. Everyone, but lots of people are building data lakes, right? This is a common thing. You get a lot of leverage by getting all the data into one place. That's great. We do that, hard problem. We all see the hardness of that problem. What do you do when you get it there, right? How are you going to consume it? How are you going to curate it, right? How's that going to happen? I saw this movie again. I just triggered the same kind of insight of what the dream is that the dream is the dream is Spark. We should embrace Spark as the elastic data consumption and curation platform to harness the power of the data lake. All data sets should be available as easy accessible RDD data frames. And then this will enable, and this is also a theme that we're seeing, by embracing this will enable the potential to have lineage of data set to transform to data set. So what about integration, right? So this is a thing that I think, as an insight that we've had, that I think in the enterprise will have a lot of potential for other people to embrace this. So one of the things that we started thinking about, and again, that talk sort of resonated with what Spark could be leveraged to do, is to integrate it fully into our existing IDEs and development SDL environments. Right? Not as a separate thing, not as a separate batch thing, but integrated. Right? And that is possible given the frameworks that we have to treat Spark like any other Scala library or any other Java library or Python library and just call out to it and integrate it into your existing platform. And just treat it as something that you now have massive scale to express certain parts of your application. And particularly this piece of code that I sort of highlight here, which I promise we will contribute, more than that, just those three lines, but what's behind that, is the ability to, at runtime, deploy code that you're working on in your own environment or in 2 different application environments to the cluster in real time, which enables a very powerful new abstraction, right? So the picture below would allow you to, in a single Spark cluster, have IDEs and production and actually batch process jobs sharing the same cluster by dispatching the code at runtime. But even more interestingly is what it would enable for debugging. Right? One of the things that, once you get beyond the kind of simple kind of transformations, one of the things you're going to want to do that you can now do that you never could do before is real-time debugging of code on a distributed cluster, right? Step by step. I mean, and it sort of just fell out so gracefully by the fact that you have these lazily evaluated data pipelines, Lambda closures that are going to dispatch code and whatever is needed to the cluster in real time. You can now, and this is an example of what we've gotten working, is in an IDE, you can have your Spark code, you can put a breakpoint in midway through your data pipeline and evaluate what your RDD or data frame looks like at that point and basically short circuit at that point and debug. So in this example, I'm literally running a debugger across, a significant size cluster with a breakpoint midstream. I can now, and I'm actually bringing up what my data set looks like midway through that stream. You could never do this before. Right? This was something that just fell out, just using using that little bit of packaging up what my current space looks like with the ability of what Spark already allowed you to do of adding jars at runtime. Transformative. That's all great, right? This is, clearly there's what are the challenges ahead, right? As Jan talked about, just getting machines provisioned to run Spark, non-trivial. Deciding how we should configure this. Should we run it on the same cluster, a separate cluster, what are the challenges? And most interestingly, and particularly when you think about this integration, which again, in the enterprise I think becomes very relevant, is you now have the dependencies between your version of your libraries for Spark and HDFS and your driver program that have to be synchronized. Right? This is a non-trivial task as we went through trying to do this a couple of times. And just when we got it working, we had to move to the next version of Scala. So it's non-trivial, and the Hadoop vendors, for all what their greatness they're trying to package, they only solve part of the problem because it's not including all the other dependencies that you have. Is enterprise data going to the public cloud? Right, I laid this out as a scale arbitrarily before I was on each side. It's probably not the only 4, and wanted to make it seem like the scale could tip at any moment. But there are clearly advantages that will come to going to the public cloud and leveraging the infrastructure that we have available to us to manage the clusters, manage platforms. At the same time, what's preventing it from happening, right? Having the ability to, what are regulations companies have, or having, how do you encrypt and how do you, you want to have a single cloud, lock-in. Right? There's things that are hanging in the balance. But fundamentally, the big problem that I think is a theme you'll see, Spark solves a really key problem of now allowing you to focus on the scalable compute that you can actually deliver the big impact and what was missing. But ETL of your data is still the big problem, right? You still have to get, moving data is still hard, right? It's easier, all the connectors and all that's great, but getting your data, getting the right data, and making sure it's all lined up, everyone agreeing upon it, is huge. And particularly in the finance space, and I think probably in enterprises in general, you have a lot of companies ingesting, getting data feeds from the same data vendors who basically take their databases, extract them, and dump them to files. And now each enterprise now has to take those files and reconstruct these databases, and then load into their data lakes, and then trying to rationalize with each other. This is a hard problem. And this seems like the amount of people time, I don't know if in this room or just beyond, that's being consumed to do this is enormous. Now, I'm going to make an observation. It's one of those kind of Heisenberg observations that it will either have the impact to help it happen or prevent it from happening. but I think it's worth making an observation anyway, because I think the potential is great, and the embracing of Spark as the lingua franca to make this happen, I think presents humongous opportunity. So I believe we're on the verge of a great game-changing event, since Lake was taken and cloud was taken, so of cloud data exchanges, right? Where you can have a notion of loading data once into the cloud. Data vendors loading their own data into a unifying cloud data exchange. Enterprises loading their data sets alongside securely in those data exchanges, but never have an ETL again. Right? An ETL once model presents an enormous opportunity of all that time and resource that are spent in doing this, and just how hard ETL is doing it once. Right? And now you no longer have to have each enterprise reloading the same data. I truly believe that this is the kind of game-changing event that will really tip the scales. It's these kind of huge economic impacting cloud data services that will really shift the balance and make it not a question of who has the right security model or lock-in or versus regulation versus management. It'd be like you could not possibly do this without Spark as a way to embrace the data and having you no longer have to load all your data in multiple times. Right, so picture something like this as that Heisenberg observation of where vendors would load their data once into the cloud, enterprises loading it alongside, and the ability by this data exchange to spin up on demand Spark or SQL or some hybrid clusters close to the data efficiently, without having to move data, without having to get stale data, without having to reprocess data feeds. So takeaways. We need to whoever is already, I commend you. Whoever isn't already, having the muscle memory to streamline, be able to contribute to this space that we are we're only tapping, what the potential here to be able to contribute to open source. At this point in time, when I've tried to actually get this process going, the number of people I had to talk to was enormous, and that has to clearly break down. And we need to shift the risk profile from the risk of contributing from the risk of not contributing. Think of Spark as the Spark Client API as an ODBC, JDBC, but with a much more verbose, much more concise, less verbose way to express what you're trying to do. And most importantly, we should all be looking to embrace Spark, embrace these APIs, and prepare for this accelerated move of enterprise data to the public cloud. Thank you very much.